Hello students. So today in this lecture I'm going to discuss a very basic concept, and that is the concept of the atomic mass, which we have been using so often, but many times the students don't understand exactly the concept behind it. So let's start with the relative atomic mass. Now, how do we find out the atomic masses? Because you can easily understand that it is impossible to weigh individual atoms. So what do atomic masses actually mean? So chemists have developed what is called as a relative atomic scale. So the atomic masses that we talk about or we refer are not the actual masses as measured in grams, milligrams or micrograms, but rather they are relative atomic scale. So it becomes something very easy to use and understand. So the atomic mass of an element refers to its mass, but in comparison to some other atom which has been taken as a reference or standard. Now you know that nowadays we have the mass spectrometer that can be used to find out the exact atomic masses. It is a sophisticated instrument which was developed and invented around 1940s. But then the atomic masses have been in use by chemists since the 1850s. So during that time, it is very interesting to know that how they were able to determine the atomic masses, which were found to be more or less accurate after the development of the mass spectrometer. So the earlier chemists actually found out by experiment the masses of the elements which were combining in particular compounds. For example, when they decomposed hydrogen chloride gas, they could easily measure the amount of hydrogen and chlorine obtained by the decomposition, and they found out that the masses were in the ratio of 1 is to 35.5. So if for convenience we take the mass of hydrogen as 1 unit without taking into consideration its actual mass in grams, then it becomes very easy to say that the relative atomic mass of chlorine should be 35.5. So when we talk about the relative atomic scales, the numbers are really easy to understand and comprehend. So the atomic masses are relative atomic masses, and since 1961, the carbon isotope with a mass number of 12 has been adopted as a standard. But previous to that, the reference was hydrogen, as you already know. But since isotopes were not known at that time, so the relative masses were not found to be accurate, and therefore it was necessary to change the scale, and it was changed to a carbon 12 scale. So when we say that the atomic mass of oxygen is 16, actually it means that the atomic mass of oxygen is 16 on the scale in which the mass of carbon is 12. So when we say that the atomic mass of magnesium is 24, it means that one atom of magnesium is twice as heavy as an atom of carbon. So we have the relative atomic mass denoted as AR of an element tells us how many times on an average an atom of that element is heavier than 1/12 the mass of an atom of C12. So let me explain you the concept behind 1/12 of the mass. See, the mass of a single carbon atom is 12 units by convention, because it is almost 12 times heavier than a hydrogen atom. So if the mass of a single carbon atom is 12 units, then 1/12 of it will be 1 unit. So this is important to understand. 1/12 of a carbon atom mass is 1 unit. So now when I say that the AR of oxygen is 16, it means that uh, on an average, the atomic mass of oxygen is 16 times heavier than 1/12 of a carbon atom, not 16 times heavier than a carbon 12 atom. So this is what you have to understand, and therefore we get the definition of relative atomic mass as the average mass of an atom of carbon 12, which should be divided by 12 to get 1 unit, and then this is the number of times that atom is heavier than that. So this is what you have to understand: the mass of one carbon atom, 12 carbon 12 atom divided by 12. So when you rearrange it, this 12 goes up in the numerator and you get this, the the formula for the relative atomic mass that now you can very easily comprehend. But as you would have come to know that after the development of the mass spectrometer, it was found out that the atoms consisted of the elements consisted of isotopes. That means the any single element did not have atoms of the same kind, but rather there could be atoms having the same atomic number, like 6, but the different mass numbers like 12, 13, and 14. So the 6, the atomic number, denotes the number of protons or the number of electrons, and this is actually the property which determines the physical and chemical properties of an element. This is the concept, the atomic number on which the periodic table has been made. But the difference between the two gives you the number of neutrons. So here there are 6 neutrons, here there are 7 neutrons, and here there are 8 neutrons. But the number of neutrons does not have a significant impact, any significant impact on the physical and chemical properties of carbon. So it's impossible to distinguish between isotopes unless we have a sophisticated instrument like a mass spectrometer, which separates the isotopes according to their mass. And now we have different kinds of isotopes. So if you have to find out the mass, the atomic mass of carbon, then we have to consider all the different kinds of carbon atoms for calculating the atomic mass, and that is called as the weighted average. So since chlorine has two isotopes, chlorine 35 and chlorine 37, what should be the atomic mass? Now the average is not 36. The reason is that the 36 is a simple average, but we have to consider the abundance also. Now the abundance of chlorine 35 isotope is 75%, and the chlorine 37 isotope is 25%. And obviously this can only be found out by using the mass spectrometer, which separates the isotopes according to the mass, and also calculates their abundances. So you will understand that later on when you consider the construction and working of the mass spectrometer. So now to find out the weighted average, if you have 100 chlorine atoms, out of that 75 atoms have a mass of 35 units and 25 of them have a mass of 37 units. So the average is called as the weighted average, and if you apply this formula, you will get the isotopic mass of 35.5, which is measured up to 1 decimal place. Now the atomic masses can be measured up to 2 decimal or more decimal places depending upon the accuracy that you require. So you understood the basic concept behind the atomic mass, the relative atomic mass. Now, so now you understand the definition of relative atomic mass, which is the weighted average mass of naturally occurring atoms of an element on a scale where an atom of C12 has a mass of exactly 12.00 units. But there is another term called as the relative isotopic mass. So when you consider relative isotopic mass, then you are referring only to a particular isotope. You are not considering the mixture of isotopes. So the relative isotopic mass will not be a fraction, it will always be a whole number, because we are considering a single atom of a single kind, whereas in relative atomic mass we are considering all the isotopes of that particular element. So this is the relative atomic mass, and similarly the relative molecular mass of a compound can be found out if we add up the relative masses of all the atoms which are present in the molecular formula of the compound. So hope you have understood these concepts very clearly, and hope you enjoyed the lecture and also understood the points. If you like the lecture, please give it a like, and whatever comments you have, please write down the comments and subscribe to the channel. Thanks a lot.